something may not happen here. What do we got here? Okay, well, I know, yeah, that's lead nitrate, but what's it going to be on the right-hand side? Okay, PB is going to get together with the iodine. Now, if it's lead 2 over here, what does it need to be on this side? Lead 2. Now, last time I told you to pick the smallest one because it's an oxidation process, but over here, I didn't say that. I said whatever it is on the left, it'd be the same thing on the right. So what if you had lead 4 over here? Lead 4 over here, period. All right. Are you yawning on me? Yes, you are. Okay. Plus, what's left over? Potassium nitrate. All right. Well, the top one's balanced, right? Is this one balanced? That one's balanced. We got a lead, we got a lead. We got 2 nitrates, 2 nitrates, 2 potassiums, 2 iodine, 2 iodine. Now, I'm going to let you use a cheat sheet, but I want to talk through it before I show you the cheat sheet. Look at your periodic table. Okay? Do you see sodium, potassium, rubidium, cesium, and francium? Those are group 1. If it's got a group 1 in it, and you put it in water, it's going to dissolve. So will this dissolve? Yes. Okay? Now you know that common sense. You just told me when you sprinkle salt and water it dissolves. You didn't need to know the group 1 rule. Well, here's why. It's got a group 1 thing in it. It'll dissolve in water. Okay, that's what AQ means, by the way. Aqueous. That means you can dissolve it in water. Okay? What about silver nitrate? If it's a nitrate, it'll dissolve. Period. Anywhere you see a nitrate, it will dissolve in water. That's a wonderful thing for fertilizer, right? If you had a fertilizer, do you want it to dissolve or not to dissolve? You want it to because you want the plant to suck it up in the plant, right? Does that make sense to you? Now, naturally, they make fertilizer you put out on the ground that slowly dissolve, but chemists have had to work very hard to get it to slowly dissolve so it won't just rush the plant with a gob of nutrients, right? It'll do it over 3 or 4 weeks. But generally, I mean, unless chemists have went through great care to make this slow dissolving, it's going to dissolve. What about this guy here? Will that dissolve in water or not?
Yes.
Yes. Why?
Because they're both dissolving.
That's it. This is a double whammy. Everything with sodium in it dissolves, right? Period. But if that ain't good enough for you, everything with nitrate in it will dissolve. Now let's look at chloride. If it's got a halogen in it, it will probably dissolve. So if you're on an MCAT test, a PCAT test, and they say, well, does tungsten chloride dissolve, and you don't know a damn thing about tungsten chloride, you need to say yes. What if they say that technetium chloride, will that dissolve? Yes. If it's got a halogen in it, say it's going to dissolve. There are 3 times you would be wrong. And that is if you had a silver, a lead 2, or a mercury. You would be wrong. Those things are rocks. They ain't going to dissolve nowhere. That's a solid. Will this reaction happen? Yes. Why? Because this is AQ, 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 something that is not AQ, the reaction will run. If it was AQ across the board, there ain't nothing going to happen. Now, does this make sense? Do I need to talk about this one more time? AQ, 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 something that is not AQ, it will go. This reaction will run. What will happen is you're going to take something clear and mix it. You're going to get milk. We're really not going to get milk. You're going to get something that looks like milk, and that milk is going to be this. Now look at here. Is this soluble or not? Yes, it's a nitrate. What about this joker? Yes. All right. What about this joker? Yes. All right, Bonnie, what about this lead 2? Solid. A rock. It's going to the bottom. It's bright yellow like the color of that folder. We're talking about rubber duck yellow. Okay? So it's really kind of neat to watch reaction 2. Clear things immediately go rubber duck yellow. Okay? And the rubber duck yellow is your lead 2 lead 2 iodide. What's that now? Iodine's just I2. Now iodine is a dark brown crystal. That's what iodine is. Okay? Is this reaction going to run? Yes. Remember, there's something there that ain't AQ. Look at here. Potassium chloride and sodium iodide. Potassium chloride is diet or salt, right? If anybody's goes to the store and you go into salt, you got normal sodium chloride, but then in the blue container, you've got dietary salt or salt substitute. The salt substitute's this guy, potassium chloride. It's also found in Gatorade. It's an electrolyte. So do you think that's going to dissolve or not? Sure it is, right? Because number one, it's got potassium in it. And number two, if it's in your Gatorade, of course it's dissolved. There's no solids in your Gatorade. Look at here. What about sodium iodide? That's going to dissolve too. It's got sodium in it. Okay. Now when these guys switch partners, what's it going to make? Ki and sodium chloride. Now sodium chloride soluble in water? What about Ki? Yes. Does this reaction happen? No. And by the way, on a test, if you put this, that would be wrong. You know, if you predict something to happen, but then it really don't happen, that's considered a wrong answer, right? So what you would do is you would just simply cross that out and put down no reaction. Because naturally you will probably want to switch it and just see, okay, and then draw it out and say no reaction. I'm not going to answer your question. What you want?
So if it doesn't dissolve, if it's solid, then that means that it's going to have a reaction. But if it all dissolves, it won't have a reaction.
That's right.
Everything dissolves.
That's right. If you see an S, there will be a reaction. Or an L, which means a pure liquid. Name an example of a pure liquid. Just a liquid. Water, right? If this ain't got nothing in it, that right there is just a pure old fancy liquid. There's others, benzene, toluene, xylene, some of these paint thinners and organics. We'll never see any of that in this class. H2O is a, say it again, H2O is a, H2O is a, so what if something produced a liquid? Would it happen? Okay, let me start over. No, I'm just playing. All right, let's take hydrochloric acid, HCl, and let's react that with sodium hydroxide. All right, looky here. What type of reaction is this? Double replacement. Good. Okay, the positive end is hydrogen here, right? And the positive end here is sodium. So what's going to happen when they play switch?